So what's become super popular, Paulo already mentioned this, is to use graph clustering. So here is actually just the graph of thrones, interactions between characters in Game of Thrones. And I want to talk about some terminology when it comes to graphs, because we have nodes. So in single cell data, each cell is a node. Any connection between two cells is an edge. In this case, we have directed and weighted edges. In single cell data, we might have weighted edges, but not directed in most cases. We talk about connectivity for each cell. So that's basically the number of edges one node has. We can talk about communities. So in graph theory, they don't call it clusters, they call it communities, but it is basically clusters. And we can also talk about hubs in the network. I don't know what's happened to my mouse. There. Nodes that are very highly connected, we can call hubs.
I have a question on the previous graph.
Yeah.
I understand how in the graph of thrones, what would define the edge, but in like cells, what would define the edge and the connectivity?
Okay, we'll talk. So it's defining, we have to define a similarity measure. I'll come to that because for all these methods, a very key thing is that we have to define how we measure similarity. And then if we go to, for instance, a k nearest neighbor graph, then we decide that in whatever space and similarity measure we're using, we take the k nearest neighbors. So if we set k to 9, every cell will have an edge to the 9 nearest neighbors. And that can be PCA space, it can be, or Euclidean distance in PCA space, it can be correlation to other cells in whatever space you're using. So an edge between two cells means that they're very similar, they're close to each other in maybe the 30-dimensional space of 30 principal components. Was that clear?
Yes, thank you.
Yeah. And we will mainly during this course talk about KNN and SNN graphs. So KNN graph is what I explained. First you have your distance matrix and you take the smallest distance from one cell to any other cells, the 9 smallest if k is 9, for instance, and then you create edges. Then we can refine that graph by creating a shared nearest neighborhood graph. So basically we take the KNN graph and we calculate how many shared edges does two cells have. And we score then the edge between those two cells based on how many shared neighbors they have. And this can be done in several different ways. But I have an example here. Not very good resolution, but still it's, here we have the KNN graph. And we see like this group here, they have a lot of shared neighbors. So these edges get high scores, while it doesn't share so many neighbors to this cell here, like this cell and that cell only shares one neighbor actually, which is that one, right? So in this case, this edge gets such a low score that it's actually removed. And this is a process called pruning. So we can also prune the graph to remove edges that share very few neighbors. So, and then of course we can measure how we have shared neighbors in many different ways. But the most common measure to use in single cell data is the Jaccard index. So basically it's how many shared neighbors does two cells have divided by the total neighbors that both of the cells have. So it's the intersection divided by the union. There are like other measures. You can just have the number of shared neighbors, the overlap coefficient, and rank based measures. But the whole idea is just in this graph we created, the KNN graph, how similar are two cells. Because I should also mention, maybe I'll come to that later, sorry. And then also, as I said, we can do pruning. So we can remove edges if the Jacquard similarity or whatever measure we're using is lower than a cutoff that we defined. So in this example, it's a shared near neighbor with pruning. So when we create graphs, I think Paulo also showed this, it can easily be represented as an adjacency and weight matrix. So the adjacency matrix is basically just zeros and ones. So node B, or cell B in this case, has edges to cell A, C, and D. And cell D has edges to B and E and F. And this is what you would get if you do a KNN graph in these single cell packages. The KNN graph will only be zeros and ones representing which are the 9 closest neighbors. Well, here we have a weighted graph, and that's normally what you do when you do the SNN graph. You get weights based on the Jacquard index.